Namaste. This is the topic of my presentation, design and simulation of ultra-wideband MIMO antenna with dual notch band. These are the topics which I am going to discuss in the presentation. I'll start with the introduction. Wireless communication has immense involvement in our lives. On MIMO systems, the concept of diversity is exploited in order to provide the receiver with different versions of the transmitted data. One of the applications of MIMO is using it for ultra-wideband technology. Ultra-wideband MIMO technology enables operation over a wide band, thus increasing the channel capacity. Here the specifications are provided of our design, the notch applications, the size, the bandwidth and the isolation of the MIMO antenna. These are the main two papers which we have followed. The L slot have been taken from the first one and the SRR from the second one. The ideas and plots have been followed. Other references are also followed, but these are the mains. These are the steps which we have considered for our design process. The first was to design the ultra-wideband monopole antenna and optimizing it for desired results, like introducing of rectangular steps near the feed and asymmetricity. The next was to install slots for notches. L slot is introduced in the patch for lower frequency. The other L slots are also introduced, but no significant changes are seen. So SRR is introduced for higher frequency near the feed. The next step was to use the ultra-wideband monopole antenna with dual notch to form MIMO with good isolation. For the isolation, we have used slots and stubs in the ground. Here, I'll start with the preliminary design of the monopole structure, which is selected for the miniaturized design of a ultra-wideband antenna, as here in the figure. The dielectric substrate used is FR4, the details are given. The steps are introduced near the feed here. The gap between the patch and the ground has played a vital role in determining the bandwidth. The nearer the steps to the ground, it contributes to the higher frequencies. The dimensions are also responsible for the bandwidth. The details are shown here. The asymmetricity is also introduced for impedance matching. Here we have shown the S11 plot. We can see the bandwidth here ranges from 3.3 GHz to 10.4 GHz. The next step was to install slots. The slots are implemented for the notch frequency band. The surface current distribution around these slots are shown in later slides. The approximate resonant formula, frequency formula is given. These are the SRR slot and L-shaped slot. It is seen that the resonant frequency depends on the dimensions of these slots. Here the S11 plot is shown. It is seen that the two notches are introduced, which is above -10 dB. The bandwidth range is given. The upper frequency bandwidth is for SRR and the lower one is for L slot. The applications are cited. This is the realized gain plot. Here at the notch frequencies, the gain is minimum, so the antenna is not radiating. The overall gain is around 5 dBi. Next, this is the surface current distribution which is shown. The L slot here is equivalent to the resonator at lower frequency, which has a resonance effect on the antenna. Most of the surface current energy is concentrated on the slot, and the antenna almost cannot radiate outside. Here at the figure B, it is also shown that the antenna is not radiating at the higher frequency. The next step was to use the ultra wideband monopole antenna for designing the MIMO structure. Here we can see the stubs and slots are introduced and at the ground plane, without which, in order to achieve the similar isolation levels, the ground plane need to be very large to make the separation between the elements larger. Here the violet colored plot is for S21, which shows that the average S21 is minus 17 dB, which shows a good isolation in nearby the antenna elements. This is the surface current distribution in MIMO. The surface current is mainly concentrated on the right port 1, which is considered this element, and which successfully decouples both the elements. The stubs and the slots, the surface current is mostly concentrated. This is the formula of ECC, and the ECC plot has been shown. As we know that the ECC must be less to signify decoupling of the MIMO antennas, and which gives a good diversity characteristics. Here we achieve 0.2 ECC. These are the conclusions which we can infer from the design. The size, the bandwidth, and the results are satisfactory. These are the references which we have followed. Thank you.